Hi guys, I'm Jan Errol Carambias and I'm with Shane Blaze Palisbo to discuss data warehousing. There are four objectives in this discussion. The first objective is to give the two important reasons why information gap exists, and the second objective is to list the two major reasons why most organizations today need data warehousing, which is to be discussed by me. And the two other objectives is to name and briefly describe the three levels in data warehouse architecture and to describe the two major components of a star schema, which is to be discussed by Shane. But before we proceed with these objectives, we must understand what is data warehousing first. We will gonna know its definition, its basic concepts, and its history.
Hey everyone, our topic is all about data warehousing. And before we proceed about the other information of data warehousing, let us first understand what is a data warehouse. A data warehouse is a subject-oriented, integrated, time-variant, non-updatable collection of data used in support of management decision-making processes and business intelligence. The data warehouse benefits users to understand and enhance their organization performance. The need to warehouse data evolved as computer systems became more complex and needed to handle increasing amount of information.
There are four basic concepts of data warehousing. First is it is subject-oriented. Major subjects may include customers, patients, students, products, and time. The next is it is integrated. Basically, it means that the data warehouse holds one version of the truth. Next is it is time variant. And it means that the data warehouse is entirely contained within a time period. And lastly, it is non-updatable. It could be loaded and refreshed but cannot be updated. And we will gonna also know why did data warehousing exist. Data warehousing emerged as a result of advances in the field of information systems over several decades. The following are the key advances. First is improvements in database technology, especially the advancement of Relational Database Management System or the RDBMS. And next is advances in computer hardware, distinctly the exposure of cheap mass storage and parallel computer architecture, and also the emergence of end-user computing and advances in middleware products. Let's proceed with our first objective. The first objective is to give the two reasons why information gap exists. The first reason is the disorganized arrangement of developed information system and their supporting database for many years. Time constraints and the lack of resources causes organizations to only focus on one system at a time. Time constraint can affect decision performance. Time-constrained decision maker process information faster, which also means that they process less information and use less accurate decision strategies. This approach could possibly produce a mixture of disorganized and inconsistent database. The second reason is most systems are developed to support operational processing with little or no thought given to information or analytical tools needed for decision making. By the way, operational processing is a term used in data warehousing that refers to a system that is used to process the day-to-day transaction of an organization. Most businesses have no idea how operation processing works and the tools needed for it. That's why information gap exists. As a result, they oftenly buy or build operational systems that do not integrate or correlate well with their existing systems in the business. Let's proceed with our second objective. Our second objective is to know the two reasons why organizations need data warehousing. So the first reason is a business requires an integrated company-wide view of high-quality information. The fragmentation and inconsistency of data in operational systems causes order data retrieval becomes less efficient and reduces database performance. Data warehousing could eliminate this problem with the use of data integration. The benefit of a data warehouse enables a business to perform analysis based on the data in the data warehouse. So the next reason is the information systems department must separate informational from operational systems to improve performance dramatically in managing company data. But why would informational and operational systems need to be separated? A separate data warehouse eliminates much of the contention for resources that results when informational applications are combined with operational processing. A properly designed data warehouse adds value to data by improving their quality and consistency. With this process, they can achieve high performance on both systems.
The three levels in a data warehouse architecture: the bottom tier, the middle tier, and the top tier. The bottom tier is a warehouse database server that is almost always a relational database system. Like, how are the data extracted from this tier in order to create the data warehouse? Data from operational databases and external sources, such as customer profile information provided by external consultants, are extracted using application program interfaces known as gateways. The middle tier is an OLAP server that is typically implemented using either a relational OLAP model, that is an extended relational DBMS that maps operations on multidimensional data to standard relational operations, or a multidimensional OLAP model that is a special purpose server that directly implements multidimensional data and operations. Lastly, the top tier is a client, which contains query and reporting tools, analysis tools, and or data mining tools like trend analysis, prediction, and so on. The two major components of a star schema are fact table and dimension table. A fact table is found at the center of a star schema surrounded by dimension table. A fact table consists of facts of a particular business process like sales revenue by month, by product. Facts are also known as measurements of metrics. A fact table record captures a measurement of a metric. Fact table contains measures or business facts. A dimension table contains the textual descriptor of the business. A dimension table is a table or entity in a star schema that stores detail about the facts. For example, a time dimension table stores the various aspects of time such as year, quarter, month, and day. Dimension tables store descriptive information about the numerical values in a fact table. For example, dimension tables for a marketing analysis application might include time period, marketing region, and product type. Dimension tables describe the different aspects of a business process. For example, if you are looking to determine the sales target, you can store the attributes of the sales target in a dimension table. Dimension tables group the data in the database when the business creates report. For example, you can group sales targets by country, product, or retailer, and those groupings are stored in dimension tables. Each dimension tables contains a number of columns and attributes that are used to describe business processes. Since the data in a dimension table is often denormalized, the dimension tables have a large number of columns. The dimension tables contains fewer rows of data than the fact table. The columns of a dimensional table are used to create reports or display query results. For example, the textual descriptions of a report are created from the column labels of a dimension table. There are 6 following points when you create your dimension tables. First, the grain. Each dimension table has only one element at the lowest level of detail, and this element is known as the grain of the dimension. Second, the non-key elements. Each non-key element should appear in only one dimension table. Third, time and date dimensions. You will typically have multiple time and date dimensions in your dimensional model. Fourth, number of dimensions. Dimensional models typically contain only 10 to 15 dimension tables. If you need more dimension, merge those dimension tables into a single table. Fifth, creating one-to-many relationships. The rows in a dimension table establish a one-to-many relationship with the fact table or outriggers. And the last, shared dimensions. Typically, dimension tables that are shared by multiple fact tables are called shared dimensions. If shared dimensions already exist for any of the dimensions in the data warehouse or dimensional model, you should use the shared dimensions. If you are developing new dimensions that may be used across the entire enterprise warehouse, you should develop a design that anticipates the needs of the enterprise warehouse. Okay guys, that's all for this discussion. I hope you learned something and thank you for listening. Bye!